I've had a crazy day. I will tell you the story when more people join. But thank you for joining. Welcome, welcome, welcome to the live. Welcome to this video. If you're watching this as a video upload later on, good evening, good morning, good afternoon, Australia, New Zealand, Finland, Iceland, USA, France, India, Pakistan, South America, Africa, everybody. Welcome to our live as usual. I have my hot chocolate ready. So I am good to go with the stories of today as soon as people join. Ooh, I'm gonna share the live. So long story short, my car was under a lot of snow. And so I dug it out and I scraped it. Lots and lots of snow under which there was some ice, but I figured it out. But it was very cold out. We're in sub-zero temperatures. Well, sub-zero as in under 0 degrees Celsius, but in Fahrenheit too, it might become sort of like feels like a negative temperature. So it's pretty cold here in Boston for a few days now. We had a bunch of snow on Friday, and after that it has been a very cold weekend. So I dressed super warmly, went outside, avoided slipping on the stairs, on the sidewalk, on the ice, and then I started digging out my car and scraping my car. How are you guys? Welcome to the live. How are you? We are live. Merry Christmas. I'm wearing Christmas colors. Merry Christmas, and if it's your Monday, happy Monday, and I'm hoping that many of you are going to be off work and school this coming week. Maybe you have a bit of a time off, so hopefully you enjoy that and can join my lives, because I've been trying to go live sort of during the day. Today I'm going live sort of late again because I've had this crazy day. It took me maybe a couple hours. Ooh, so I dug my car out, scraped my car. Hi, freaking boys. Hello, how are you? So I dug my car out, scraped my car. It had auxiliary battery malfunction issues. I'm fine, good. Thank you for joining our live. So then I realized that it was very low on this battery charge, and it just like felt very different. Like there was this like vibration in the car that I was feeling that I generally never feel. So I was kind of freaked out, but then I gave it some time. I kept it running. Where are you from? I'm in Boston, Massachusetts of the United States of America. Where are you from? And this is my car story of today. Usually I share kitty cats and physics stories, but today I've had a rough car day. Okay, why is it not letting me? I'm from India. Oh, nice. I'm also from India originally. I grew up in India, but I'm in the US now. Which part of India, my friend? Freaking boys. So yeah, I'm sorry I'm going live so late again for my US people. Yes, please please share the live and like the live is what I was gonna say, but if you could share it, that would be amazing as well. I am from Hyderabad. Hi, Cole Christensen. Do you mean Hyderabad? Or maybe... Hi, freaking boys. Hi, Cole Christensen. I am from Hyderabad. Hyderabad? Hyderabad? I know Hyderabad. So that is the story. My car battery was very, very low, but I kept it running. So at first I'm like, oh my God, what's gonna be happening? Like, what things will not work if my battery is low in the car? But then I kept it running, and then I started to drive it. And of course it wasn't that like snow-covered little ditch at this point because it had been standing in the street parked in the snow. So it was a little scary. So then I kept it driving, kept it running and driving because I'm like, okay, the battery needs to be charged by the running engine. So I'm going to keep it running, keep it running, keep it running. And then I started driving towards a garage, a parking garage. Now, luckily, the parking garages are free on Sunday. Well, some parking garages. So I took it to a parking garage that's free on Sunday. I go inside and I scraped more and I kept it running more and just kind of making sure that it's working and things like that. And then I brought it to another place where I wanted to eat dinner. And finally, I got food and then I felt happier. Anyway, that was the story. How are you guys? We are live. I just hope that I've solved my issues and that there are better situations going forward for this car and the snow that's upcoming. There's going to be apparently more snow coming up. So yeah. Okay, well, if we have a white Christmas in Boston, I will let you know because I will try to go live when it's still like daytime and you can see outside and hopefully see the snow and the white and everything. Hi Fuji. Oh my gosh. I have my hot chocolate here. Okay, so once again, welcome. Thank you for joining. It might be a very quiet live. I don't know. Maybe people are already asleep. Maybe I'll do a little bit of a physics topic discussion and go to bed. And you can see this later on as a live or as a video upload later on if you're seeing this later on. And if you're joining right now, well, thank you so much for joining and welcome. Let me share it again just to make sure that people are getting the live link and everything. So yeah, okay. This is my life. I go live and I try to share as much as I can. All right, so yesterday when I went live, one second. I was talking about particle astrophysics from my own thesis or no, was that yesterday? No, that was couple days ago. Couple days ago, I went live and I covered my own thesis. But now, yesterday when I went live, one of you asked me questions from quantum mechanics and we covered that. Today, I might just cover the particle astrophysics topic again, like continuing from where we left off. We had a really nice long discussion a couple days ago on the particle astro topic, and then we were just like hanging out, chilling and eating soup and chatting and breathing. So that was all from a couple days ago. And then yesterday I went live and somebody had questions from quantum mechanics, so we covered that. So today I'm thinking I will continue the particle astro if there isn't any new input from anybody. I might even take some sips of my hot chocolate first, actually, if it's gonna be so quiet. Yeah, okay. All right, so I think I have shared the live now, and here's my laptop, and hi everybody. And okay, so this topic that I'm sharing, it's called Studies in Particle Astrophysics. It's my own thesis, and I had just talked about ANITA, Antarctic Impulsive Transit Antenna, when I last talked about this. So if you were here, you might have gotten the introduction of particle astro and cosmic messengers and optical Cherenkov and radio Cherenkov and all that stuff already. Were you here a couple days ago? Anybody? Oh, that's good. Ah, that's good. It's so cold today. I scraped my car in the cold, but I dressed very warmly. I wore some thermals, same thermals that I wore in Antarctica. It's like the austral summer here, but on the ice. Ugh. All right, so let's do this thing where I talk about aura. So we had talked about Anita already, and now let's talk about the Ascarian radio array. So in contrast to a balloon-borne detector such as Anita, ARA is a ground-based experiment. So I talked about how the Cherenkov radiation that we try to detect from neutrinos interacting in the ice in the radio frequency, that is something we can try to detect either by hanging our detector from a balloon and making it, launch up in the sky. And then we kind of look down with our antennas onto the ice. And that's one way of doing it. Or we can embed our detectors directly in the ice and basically have the radio antennas. These are still going to be radio antennas, but we could have them directly be in the ice, waiting for the same kind of signature, but with probably slightly different geometry and slightly different energies. But it's sort of a similar type of concept. So in contrast to a balloon-borne detector such as Anita, ARA is ground-based and the ARA radio antennas are embedded in the ice of Antarctica. When ARA is deployed, it can potentially observe all year round, as opposed to only about a month of observation time in Anita. So something I did not mention super over super long time, but I did mention as part of the summary of flights that we did with Anita is that, of course, Anita is a balloon-borne experiment. So when it's launched, as long as the balloon is up, that's the detection time of Anita. So a balloon-borne experiment, depending on the type of balloon, these are called NASA long-duration balloon experiments. NASA long duration, LDB. So there is a NASA long duration balloon facility in Texas. It's actually in Palestine, Texas. And then there's also one in Antarctica. So I've worked at both because, of course, we go to Texas for the hang test. And then when things are good and we're good for launch, that's when we would go to Antarctica. So we don't go to Antarctica directly. First, you have to prove things out and make sure your detector is working and prove it out with NASA in Palestine, Texas, where they have, or at least they used to have, a long duration balloon facility, NASA long duration balloon facility. And then once you're good, once you're good with that, you go to the NASA long duration balloon facility in McMurdo Station in Antarctica. Hi, Crazy Sick Wine. Hello, good to see you. How are you feeling this evening? Hope you're feeling well. I am feeling better, but I've had a crazy day with some snow and ice and car situations. Good to see you. How are you? Come, Baji. Hopefully I am getting better, for sure. The warm drinks and warm soups are helping, but today I had to go outside and work on my car. So that was quite an adventure, and that's why I'm late, and here I am on my late live because I cannot sleep well without talking to you guys first on my live, because I have a goal with these lives and I must meet this goal. So anyway, here we are. So the big thing about these balloon-borne projects, even though being balloon born, as we saw with Anita a couple of lives ago. If you go catch my like 6+ hour live, that's when I started this topic of particle astrophysics from my thesis officially, and talked about Anita, Antarctic Impulsive Transit Antenna, which is a balloon-borne neutrino detection experiment. It tries to detect ultra-high energy neutrinos. Turns out it's actually a very good detector for ultra-high energy cosmic rays. That's a detail that we'll get into later on. But one big difference between having your experiment be hanging from a balloon versus embedding your experiment in the Antarctic ice directly is that if it's in the ice and if it has power, then it can probably run like all year long. Even then, there might be dead time because nothing is perfect and your power might be going down or something might be off. There could be problems with the facility. There could be repairs or maintenance needed. So even then, you probably don't get lifetime throughout the full year, if I'm being totally practical and honest. But Anita is going to be much, much more logistics restricted because it's literally hanging from a balloon. So anything that's sort of a launch type of thing where it's like launched in the sky and then there is a finite period of time during which it can function. Of course, your whatever data you collect during that month or so is what you get for that particular launch. So yeah. Oh yeah, up east is no joke. The weather is insane. I'm doing all right, hanging in there. Good. Crazy Sick Wine. You said you're in California, right? So the weather is going to be completely different. Yeah, here we're getting some northeast weather. The snow really hasn't been that bad in the last maybe year or so in Boston. But this year, we're going to get a little bit more snow than usual. Or not than usual, than last year. Usually, apparently, Boston is supposed to get a lot more snow, but we've been getting less. But this year, we're going to get more again. So my car was like under a bunch of snow. And it was sort of malfunctioning. My favorite. Not really. Touch wood. Hopefully it's getting better. So anyway, so in contrast to a balloon-borne detector such as Anita, ARA, which is the Ascarian radio array, which is the directly into the ice embedded experiment for neutrino detection, ARA is ground-based and the ARA radio antennas are embedded in the ice of Antarctica. When ARA is deployed, it can potentially observe all year round, as opposed to only about a month of observation time in Anita. Now, remember, I'm saying potentially, again, because it's never going to be fully up all year long. There's going to inevitably be issues with ARA too, because the power could be down, there could be some maintenance or repairs needed. We'll get into those details a little bit later, but basically when you do put things in the ice, it's not like you put it in there once and that's it. Generally speaking, there's a bunch of drilling work that you have to do in order to put in new ones, and that can take a long time. And if something is sort of amiss, then wow. Then it does take time to take it all out and work on it, repair it, and then put it back in. So ARA is not perfect. Nothing is really perfect. Everything in real life is like something that needs work. The completed ARA detector will consist of 37 deep stations spaced 2 kilometers apart at a depth of 200 meters. So by the way, I wrote this thesis a while ago. I'm not sure that ARA will actually have 37 deep stations or not. It might end up with a lot less than that. Last I heard, the ARA experiment may have had funding cuts, which would significantly reduce its however many stations that it ended up having. But currently, at the time of writing this thesis, which was several years ago now, this is from 2018, currently ARA has 5 deep stations in the ice. A station or a single array element consists of a cluster with around 16 embedded antennas deployed up to 200 meters deep in several vertical boreholes, placed with about 10 meters horizontal spacing to form a small subarray. So that's how Aura works. It's a little bit similar to Ice Cube in that sense. Aura is highly modular in that each station comprises a standalone neutrino detector for its surrounding ice. All borehole antennas have a bandwidth of 150 megahertz to 1 gigahertz. Like Anita, Aura 2 relies on the Ascarian effect. So it's very similar to Anita. It's also relying on the Ascarian effect, but now we're trying to catch the radio waves coming from the neutrino detection directly in the ice. For observation, so Aura 2 relies on the Ascarian effect for observation of ultra-high energy neutrinos. Aura 2 utilizes the Antarctic ice as a target medium for neutrino interactions to look for radio signatures from these interactions. The main distinction between Anita and Aura is the area of target medium or ice they each observe, and therefore the neutrino energy range they're each sensitive to. Anita observes an array of roughly 1 million square kilometer and is sensitive to very rare neutrinos of energy 10 to the 18 eV and above. Aura covers roughly a 200 kilometer squared area and is sensitive to the neutrino energy range of 10 to the 16 to 10 to the 19 eV. So that's the big difference. Hi, Yash. Hello, Yash. Hello, Crazy Sick Wine. Hello, everybody. So next we're going to talk about Aura versus Ice Cube. Let me read your comment. I'm enjoying the Malibu weather, but I've been to Boston in the early 2000s. Completely different than here, but still beautiful nonetheless. Yes, Boston is very different. Northeast is very different and cute. I like it. Yash, how are you? Do you have school off now? I hope that people are on their Christmas vacations by this point. How are you in the kitties? We're good. We're good. So let me read about Aura versus Ice Cube. Let me finish up this chapter today, okay? And then I'll catch up with you more. Stay on. I'm so happy to see you all in the live. Aura versus Ice Cube. The main distinction between Aura and Ice Cube is that Aura is able to observe 100 times bigger target volume than Ice Cube with fewer detector units than Ice Cube. So Ice Cube is a cubic kilometer of ice instrumented to observe optical Cherenkov radiation from neutrino interaction or from neutrino signatures, whereas Aura is looking for radio Cherenkov. So thank you. Oh God! How long is your Christmas or holidays vacation? So Aura is doing radio Cherenkov, Ice Cube is doing optical Cherenkov. So two different things, right? And those really do affect the scales and the volumes and the detection volumes, as well as sort of the instrumented volume of each experiment, and also the sensitivity of each experiment. So let me talk about that. The main distinction between Aura and Ice Cube is that Aura is able to observe 100 times bigger target volume. Target volume, remember, target volume meaning the volume of ice where neutrinos could potentially be interacting. So all those like really high energy neutrinos, ultra high or high energy, it could be really high energy or less high energy, but regardless, it's going to be high energy. It's not going to be lower energy like the sun's neutrinos. But these neutrinos, basically, we want it to have a target volume to be able to hit. Like this neutrino at these energies are going to hit a quark inside like the nucleus of the molecules in the ice. And so we want as big of a target volume for the potential neutrinos coming in as possible. And how we instrument that also is going to be different based on different experiments. So the main distinction between Aura and Ice Cube is that Aura is able to observe 100 times bigger target volume than Ice Cube with fewer detector units than Ice Cube. So a lot fewer detector units than Ice Cube. This is because the attenuation length This is because the attenuation length of radio signals of the frequency range that Aura detects is around 1 kilometer, allowing for, so the attenuation length of radio signals of the frequency range that Aura is detecting, that is around 1 kilometer. So I was mentioning earlier in the earlier live that ice is pretty much transparent to radio waves. But what do I mean by that? How transparent? It's not like infinitely transparent, right? Depending on the energy of the light. So in other words, depending on the frequency range of the light, we are gonna attenuate over the length of around 1 kilometer or so, okay? So now, because the attenuation length of 1 kilometer is pretty long, you know, that's not very short. Like a meter is, you know, I can't even fit it in the screen. Even a meter is pretty long, right? So 1 kilometer is like 1,000 meters. So that's not exactly short. Have you been live this weekend, or did I just miss you? Yes, I was live, but I think you were already in bed. Because I was live more like my evening time, which would be like your nighttime or very early morning for you. Interesting. Thank you, Crazy Sick Wine. Thank you for joining the live. Yay. Thank you for liking the live too. Thank you, everybody. So basically, this attenuation length of radio signals allows for aura's distribution to be kind of more sparse, like 1 kilometers apart. Whereas the optical signals that IceCube is detecting are restricted to less than 100-meter lengths. So optical light, right, which is just light, but same light as in still light, but of a different wavelength. Different wavelength, different frequency, different energy. That type of light will actually attenuate a lot faster, as in a lot over a lot shorter distance. So you can't instrument IceCube so sparsely. You need to have the detectors be present much more thickly packed, because the attenuation length is less than 100 meters for optical light. The energy threshold determines the expected flux, and thus the size of the detector. The energy threshold determines the expected flux. That's right. The other thing is that depending on which energy neutrino you're trying to go for, that also makes your neutrino flux different. And that's the size of the detector. And also the size of the detector will be affected by that. Are you sick? Yes, I am. I have been sick, hopefully better now, but I've been sick for like over a week now. Yes. Do I look sick? But yeah, kind of sick, yeah, but better now. The energy threshold determines the expected size of the detector, because the other thing is, so all of this geometry is affecting the size, but also if you're expecting neutrinos of a very high energy, those though the expected flux for that is also going to be different. It's going to be less probably than the expected flux of high energy neutrinos, but that are lower energy than the ultra high energy neutrinos. So you might want to instrument more volume if you're gonna want to go for the rarer neutrinos. So with a smaller instrumented volume, IceCube is typically sensitive to energies lower than the ultra high energy regime, whereas Aura is sensitive to ultra high energies up to 10 to the 19 EV. Thank you. So that's the big difference between Aura versus IceCube. Aura is looking for the radio Cherenkov signatures. IceCube is looking for the optical Cherenkov signatures of neutrinos. And well, there are some other differences too that are more, logistics and politics, in the sense that Aura's funding, I believe, is in much worse shape than IceCube's funding. IceCube is like the biggest, as in richest, most funded neutrino experiment. So it has seen a lot of progress, whereas Aura's funding, as far as I know, has been cut. So it hasn't even really built up to the full initial plan of however many stations they wanted. So that's another way in which Aura is different. But also basically the two experiments are complementary. They have different goals. They're designed to detect neutrinos, but neutrinos coming potentially from different sources, and also neutrinos that are different energies. And also because their detection techniques are different, their sensitivities are going to be different, and the instrumented volume for each one is also different. I will say that it is, even with less funding or more funding and very different, logistics or whatever, It's always good to have multiple experiments and multiple experiments, especially that are complementary. You don't want the same carbon copy of like the same experiment done by the same people all the time. You want basically various different efforts happening even within the family of neutrino experiments, because those complementary pieces of information and the complementary data about neutrinos will actually fill out the bigger picture that we get of neutrinos. Effortlessly exquisite. Thank you. Thank you so much. So that's the thing as well. I'm wearing Christmas colors. Merry Christmas. Merry Christmas, everybody. I'm wearing Christmas colors. I have green and red on, and I have a little bit of sparkle too in my hair. Thank you so much for being here. Thank you so much if you're watching this later on as a video upload. I'm talking about we talked about Anita last time. Yash, what are you gonna do for Christmas? Tell us your plans, and I'm gonna read it as soon as I catch a break between my readings. Tell us your Christmas plans. Are you gonna get up with your cousins, or catch up with your cousins and visit your auntie, or what are you gonna be doing? So so those are some more sort of details. So now I'm gonna, did physics come easy to you when you first started, or was it mind-boggling? I don't think anything came easy to me other than reading and writing. I was more of a literature type of person, actually. I would say more than mind-boggling, I really liked it. I thought it was very interesting and I wanted to learn more about it. And it became sort of a big passion for me. I might go out with my family or visit my grandma in Karachi. Nice. Karachi is cool. That's perfect. But the things that came more naturally to me are probably speaking, reading, writing. Like I was big on reading, big on writing. My earliest ambition was to become a writer. Like I was writing all the time, you know, things like that. And then physicist is really my second ambition. Once I took a physics class in my school in 7th grade, I really, really liked it. It really stimulated my intellectual needs, I think. And I found it to be very, very interesting. And I thought, I mean, what better than to try to understand and learn about the entire universe. So that's what motivated me. So I would say I was more just like motivated by it than whether it came easy to me. It probably didn't really come easy to me. For me, it is very interesting, but actually doing physics was quite hard for me mathematically. Oh, yeah. So math was pretty hard for me, I will say, especially in the way it was taught in India. That was hard for me because math, my introduction to math, like in my early years of math, were not good. They were kind of traumatic, actually. So it became, basically, I only got better at math because I was extremely motivated to study physics. Physics was actually the gateway for me to more math and to be able to understand and apply myself in math, because like calculus, I didn't learn calculus from a mathematician. I learned it from a physicist. So, and it became like my favorite thing in math. Until I took calculus, I think I didn't really like math, to be totally honest. What subject you think was the most easy? English? Like English literature? Poems, poetry, I loved literature, and I also like love writing. You know, like I love the arts as well. So I think the easiest subject to me was English literature. The romantic poets, John Keats, Wordsworth, that sort of stuff was easy to me. But I think I don't fully enjoy what is easy to me, is the other thing. I don't really fully enjoy. Well, I enjoy it. It's a part of me, but it's not. I need more. I need more. That's the thing. Was English hard for you when you started to speak it, or was it easy for you to speak? I think so. I went to an English medium school, so we spoke Bengali, English, Hindi. It was sort of all being taught, right? I mean, I only took a like you. So you Hindi was my third language. So my two primary languages were Bengali and English, and then I officially took Hindi, and but Hindi was also Hindi, Urdu. You know, I understood it because of Bollywood, because of the Hindi film industry, and like just you know, yeah, the invention of calculus was absolutely necessary to further establish physics, in my opinion. Yeah, and I mean, look at who invented calculus, right? So, yeah, yeah, like when like dx dt, you know, being a velocity, like basically x being a position, and you take a derivative of that, and that's velocity, and you take a derivative of that, and that's acceleration, and then you write down like f equals ma as a second derivative. Like that's how I learned math. I know that math is more than that, and you know, but that's what that's my, you know, way of learning it. Um that's okay. Yeah, I've been sick too. I'm just glad you're here now. So, was English hard for you? I will say that I think when I was super young, I wasn't sure why people were making it a big deal, like if I didn't speak English. So I think the culture around sort of like this whole like colonizer culture was hard for me. It was hard for me to understand why some people thought that English was better than the other languages. And when I spoke in other languages, I would get like reprimanded, like scolded in school, right? And I always was confused by that. So I think the culture around English was hard for me. I don't think English is that hard. I think it's this easier language out of the ones that we had to learn. I think a lot of us learn English as a language in Southeast Asia, and it's definitely not the hard one. It's the easiest one. And another thing was that when I first came to the US and I had to speak in English only to people who don't understand like two or three other languages that I knew, that's hard. Having to express a full sentence in only English is kind of hard and kind of boring, but now I'm used to it. But most people who are bilingual or multilingual will mix it up with other languages. So yeah, English is really not that hard, especially if you know other languages. It's not going to be the hardest one. I sucked at English, especially essays. I was good at it. I think I'm good at languages, maybe. I'm good at language, literature, writing, words, you know. I loved writing essays. Like, I was probably writing essays and books, like, you know, not like a novel or a story or poems in my free time. So I loved writing as a hobby, and I loved reading as a hobby. I think why I might have learned, you know, English better is because I read a lot. It was my main hobby. Where are the other kitties? Baji's right here. He's over there. I think Fuji has gone upstairs to be warmer. The upstairs is more warm than the downstairs. Yeah. This one is Suji Mama. She's in my lap. Suji. But yeah, it was even in high school, even when I was like full throttle pursuing the sciences, and like I kind of knew that I was going to major in a pure science field. But a lot of my teachers in high school actually thought that I would study English, like English literature, basically like be an English major, you know? And I was also the editor in my school, like in all of my school. They sent me to a lot of poetry competitions. Like literally they would throw me into some kind of impromptu poetry writing contest and I would win. So I think my natural talents were definitely aligned with all of that more. But that happens a lot. In science, in physics, there's a lot of people who basically have, they're kind of like multi-pronged, multi-passionate, Oh, good. Hi, Ben. Hello, Ben. Love your channel. Thank you. What makes English hard is pronunciation and spelling. No, go, and so. Why does not do sound the same? Do. Do. From now on, we can just say that. Do that. English is not a logical language as to pronunciation. That's very true. I think something like Spanish is more logical, right? Like the pronunciation is sort of matching how the phonetic thing is. So that makes sense. I think I've had so much exposure to English, like reading and all that stuff, that it became like second nature to me. So I have an advantage. Like some of the English pronunciations, I might have gotten wrong in the past because I read it in a book, right? When you read English, you might not know the pronunciation. So, you know, but that's fine. I think a lot of people are pretty good at English. It's like so common. I kind of wish now that I also had maybe taken another sort of Western world language, like Spanish or, I don't know, French or something. The main one I know is really English. I understand a little bit of Spanish, but yeah, anyway. I think English is so spoken, right? So even if you like didn't know it, you could probably pick it up because it's so common. But yeah, you are right that it's not logical. It's got different roots, right? The Latin and the German and everything. So I think definitely you're right with the illogical pronunciation of it. Anyway, so let me finish up this chapter, which is basically now a summary of the remaining chapters. So in this first introductory chapter, I am now summarizing the remaining chapters. The work presented in this thesis is with regard to the Anita experiment. So that's the main experiment that I worked on for my thesis, even though I also learned about all the other cousin experiments as well in the field. But that's mainly what we will cover. Chapter 2 describes the Anita instrument and highlights new electronics that tripled the instrument lifetime of Anita. So I talked about how, so a few lives ago, I talked about these notch filters that we built that were actually a lot of fun and that became sort of more important and more adventurous when we actually launched the experiment in Antarctica. And that particular hardware ended up being a whole paper, and it was ended up giving us really, awesome results and helped with our lifetime a lot. So that will be something I cover. Chapter 3 describes the development of a new technique for analysis known as the bint analysis with a focus on background reduction. So something that we will talk about a lot with these types of experiments is that you basically have to work on understanding your noise sources, because you're trying to detect a signal that's pretty rare. So most of your data is going to be noise. Like most of it, like large majority of it is just going to be noise, anthropogenic noise, some other noise, thermal noise, and so being good at understanding which parts are noise and what type of noise is basically the name of this game. So we worked on that, I worked on that, and that's part of this thesis as well. And then the first physics results from this new analysis are presented in chapter 4. Chapter 5 is a review of gamma ray bursts, my favorite transients, in the context that these exotic events, let me clip that. These exotic events could be sources of ultra-high energy neutrinos. So gamma ray bursts and ultra-high energy neutrinos have not been correlated or connected yet, as far as I know, but this is definitely a possibility and something that I was pursuing, and that was a major motivation in terms of the astrophysics of this thesis. Chapter 6 describes the developments in adapting the simulation and the bint analysis to a search for neutrinos from sources, specifically gamma ray bursts. Mysteries, thoughts, ideas, and associated results are presented in Chapter 7. So guys, that was chapter 1 of my thesis. It was mainly an introduction, so I thought it would be a good one to cover during these lives because it basically introduces particle astrophysics, what it really means. It's basically to do astrophysics with particles other than visible light, which includes gamma rays, X-rays, which is still light, and then particles that are completely different from light, such as cosmic rays, which could be even something like a charged proton. A proton is generally charged. I just wanted to say that cosmic rays are generally charged particles. It could be a proton, a neutron. It could be some kind of other atom or molecule even. But basically, cosmic rays can also be used to do astrophysics. And then lastly, we can also do, not lastly, we can also do astrophysics with neutrinos, another whole different type of particle. These are actually fundamental particles belonging to the lepton family, same family as electrons, muons, and taus, but neutrinos are very different in the sense that they're very elusive, they don't really have a charge, and they don't interact with any other force than the weak force through the W and Z bosons. So neutrinos are low mass, much lighter cousins of the electron is one way of putting it, one way of describing them, but they're quite different. They don't have a charge and they don't interact with most things most of the time. So neutrinos is another candidate. Baji's over there up to something, so Suji jumped up. So that's neutrinos. We discussed them as a candidate particle for studying particle astrophysics with, and in fact my thesis actually focuses on neutrinos. Lastly, we can also do particle astrophysics with gravitational waves. That too is a cosmic messenger. We have started to measure gravitational waves from far away, exotic, amazing, phenomenal type of events and phenomena, such as the mergers of black holes together, or a neutron star with another neutron star, or a black hole and a neutron star. Basically, any two massive binary system will generally revolve around each other, and as they emit gravitational waves and gravitational energy, because these are massive things with a lot of gravitational energy, so some of it is released as they're kind of doing this dance together, and they actually tend to get closer and closer together as they're doing this revolution around each other, and eventually they will collapse into each other and collide into each other. And that's called a merger of such binary systems. So you might have heard of neutron star mergers or black hole mergers or a black hole neutron star merger. Well, when such a thing happens, even if it happens very, very far away from us, hopefully, such a thing can release a lot a lot of gravitational energy, gravitational waves, which we can even measure on Earth. And we have these observatories now set up to do such a measurement. So we didn't always have this ability. In really the last under 10 years, we've had this ability to measure really like directly gravitational waves. We had indirect measurement of gravitational energy and gravitational waves in the past, where we basically saw that particular that reduction of the distance between two objects in a binary. So picking up on that is basically an indirect measurement of gravitational waves, because it means that, yeah, the system is releasing gravitational energy, and that's why that distance is getting reduced. So it's an indirect evidence, but we can directly actually measure like the vibrations or the gravitational waves from these types of events as well. And we started doing that with the LIGO observatory. So that is the laser interferometry gravitational observatory, I believe. So you can just Google it, LIGO, LIGO. So once LIGO, Baji's over there playing with his favorite toy. That's why we're looking over in that direction. But once LIGO has started to measure gravitational waves directly, we have yet another cosmic messenger. So these are all the things I just mentioned: photons of various wavelengths, not just visible light, but also gamma rays, X-rays, neutrinos, which is a fundamental particle belonging to the lepton family, cosmic rays, which are basically charged particles that are hitting the Earth all the time from various different sources, could be galactic or extragalactic. Gravitational waves, now that we can directly measure those as well from very exotic, big merger type of events, they could be measured from lesser type of events as well. We just have to have more sensitivity. So we actually have a plan of putting these gravitational observatories even in space. So if they're on telescopes in space, if they're on satellites, or if they're on satellites in space, they basically become telescopes for gravitational waves, and then they can be even more sensitive, because the ones on Earth, they have to, basically your gravitational event, the merger type of event that would be something that we can pick up on with high confidence, would have to be a rather large one for us to be able to say that, yes, we picked up on something like that. So our sensitivity is basically less, or in other words, we're sensitive to more bigger type of events, whereas we might pick up on slightly lesser type of events as well, and increase our portfolio of all the different types of gravitational waves and events that we can be sensitive to if we put the detectors in space on different satellites. So there's plans for that. That type of observatory doesn't actually exist yet. There is plans for that. But these are all the different cosmic messengers that give us the full picture nowadays in astrophysics. Astrophysics has come a long way from the hundreds of years ago, when astronomy was done mainly with visible light, with just the naked eye, and then with telescopes. But now we can do astronomy and astrophysics with light of other wavelengths, including gamma rays and X-rays, particles of other kind, such as cosmic rays and neutrinos, and even gravitational waves. So this is an introduction that I covered from my thesis, the first chapter. This was sort of a summary that I covered. And then I also talked about, more specifically, observatories that are more based on neutrinos. So particle astrophysics with neutrinos, and what type of detection methods are employed when it comes to that. So I covered optical Cherenkov methods and radio Cherenkov methods, as well as the experiments that are sort of in that field that utilize these methods. I mentioned IceCube, Ariana, Ara, Anita. So a bit of an introduction to all of these experiments are all in the first chapter that I just covered from my thesis. And I started the discussion a couple of lives ago, so that will have the bigger discussion on particle astro. And today we finished up the... Thank you. And today we finished up that particular first chapter of this thesis, which introduces to you particle astrophysics with neutrinos, but also... Oh, and another very important thing we covered is the energy regime. So I think I spent a little bit of time on that, and I showed you the slide. It was good to have the laptop. I showed you the pictures as well directly without having to like use like another screen and stream and all that stuff. But basically, the different particle astrophysics, or just in general different particle physics experiments, where they are in the energy regime is an important thing, because the physics that you're probing is different depending on which energy regime you're operating in, and the type of particle you might use, or the type of detection method you would use, and the type of setup you would use, how big your volume has to be, how big your detection instrumented volume has to be, is all affected by all of this. So it's very important to understand which energy regime you belong to and where you're operating. And even if you're operating, say, in a specific part of the energy regime, it's important to understand where everybody else is and just kind of mention all of them when you first get started. So that's what I did as well in this chapter. Hi, Ben. Hi, Crazy Sick Wine. Hi, Nausat. Nausat is saying hi, Baji. Baji, mother. Yes, Groove Toot says, I'm liking the newer lives, being able to see you talk. It's a bit more engaging, as much as I love the cats. Hello, by the way. Hi, Groove Toot. How are you? Yeah, no, I get it. I think I try to do a mix of both the cats and me. So I'll try to do a lot of these on-camera lives talking about these topics. I think that does help. And sometimes when I don't feel like it, then I'm not on camera and I still do the live anyway. So it depends. But yeah, thank you so much for being here. Thank you, everybody. I had to start a little late today because I had to go deal with the snow and ice and car situation. But in Boston here, we're getting some snow and extremely cold, sub-zero type of weather. So hopefully you're staying warm. And if it's your summertime because you're in Australia, New Zealand, or Antarctica, then happy summer Christmas to you. Antarctica's summer is still pretty cold, but there is daylight 24/7. So when I was in Antarctica, so part of this thesis is also, of course, this work is in Antarctica. So is there any good skiing up there? In Boston, you mean? Or Antarctica? Boston does have skiing in the west. I've heard that there is skiing towards the west side of Massachusetts, or maybe New Hampshire. Like Boston is really not far. It's like 30 minutes to New Hampshire. So there's a lot of big mountains. Like suddenly, you know, if you start driving from Boston and you go up, suddenly within like 30 minutes, oh my gosh, Suji was coming and running at a very high velocity here. I just wanted to make sure she doesn't spill over my hot chocolate. But yes, I have heard that there is good skiing. Not that I know, because I don't really ski myself. But I've heard people say that there's good for beginners kind of skiing in Western Massachusetts. And of course, there's always... I actually don't know if people go... Actually, I think people go to Vermont for skiing in New England. Is that a thing? I feel like I've heard people go to Vermont for skiing. Again, I don't really know because I don't do it myself much. Oh God, you should try it, so fun. Okay. I will at some point when someone makes me. If someone makes me and is willing to pay for a skiing lesson, then I will. But I don't know if I will on my own. I don't know if I'm that motivated. One time at a wedding, I had the full opportunity to go for a ski lesson, but it was in Colorado. It was in Aspen. It's like the ski capital, right? But I was too cold, and there was so much good wine and food, and warm drinks inside. Wedding in the slow. Yes, I attended a wedding in the middle of the mountains in Colorado during the winter, and people were skiing and everything. I like going to Aspen to ski and jumping in the hot tub after with some fine wine. Look at you, living the fine life. Let me refill my hot. I'll be right back. I need to make my hot chocolate a little bit warmer than it currently is. Hot tubs in the snow is amazing. Yeah. Suji's having zoomies. It's so cold. It's like my tea, hot chocolate, everything's just getting cold. You have to look at Suji. Hi, Suji. Suji, mama. Fuji. Do you put anything in your hot chocolate like peppermint or anything? Not really. Although I'm not opposed to it. I just don't have it right now. I'm not opposed to some more ingredients in my hot chocolate. Certainly. More the better. I kind of wish I had marshmallows. But yeah, thank you guys for being here. I just kind of had to like dig out my car, scrape, and kind of struggle for a few hours out there. Then I got food. Then I came back. Oh my gosh. Hi. Hi, Sachi. Hi, Sachi. Sachi's such a cute girl. Such a cute girl. And then I showered and covered myself in lotion. I'm like, it's so cold and I had to be outside. And I sat down with some hot chocolate. And then I went live. And then here I am. And and now I am hanging out with you guys. Are you a teacher? What do you do for a living? Physics, something obviously, right? Yes, something like that. Yes, indeed. Something like that. What do you do for a living? Suji mama is having so much zoomy. It's cold. Let me tell you. It's been so cold. Let me also say that we're gonna talk about gamma ray bursts. So by the way, I have a review on gamma ray bursts on Amazon. You don't have to buy it because I can also just make it available for you here. But I do have a review on Amazon. like a little book on Amazon. I have a few books, but one of them is the Gamma Burst review, and I think I will cover that as well. Work at Chick-fil-A. Do y'all have them in Boston? Why should I work at Chick-fil-A? But thank you for the suggestion. I think that there is Chick-fil-A's in Boston. Oh, you work at Chick-fil-A. That's awesome. I like the honey mustard there. The last time, sorry for the confusion, no worries. The last time I got Chick-fil-A was a very long time ago. So it wasn't really front and center on my mind until you mentioned it. I love the honey mustard there. I think I used to get a lot of Chick-fil-A in college. So I went to college at NC State in North Carolina. And so I used to get the meal and the honey mustard and all that stuff a lot back then. Now I don't really get Chick-fil-A too much. But yeah. No worries. So, as I was saying, basically, I wanted to say what the different parts of the thesis are. So we've covered the introduction, which is the particle astrophysics introduction, the different experiments, the different energy regimes, and all that. Then chapter 2 is... Oh my god. Fuji! Okay, everything is okay. It's stainless steel that just fell. So it's fine. Then we'll talk about the Anita instrument more specifically in chapter 2, because that's the focus of my thesis. So we'll see a lot of different... Ooh, you know what? I'm going to show you this. Oh my gosh, there's a picture of me from grad school. So all of that, what are your thoughts? No way, I was just there, lol. We were skiing near Boone. What, at NC State? Or sorry, North Carolina? Yes, I went to college at NC State, so I was there for 4 years. It was the first state for me here in the US where I lived, because I came to the US for college. So I was at NC State, then I went to Ohio State. So North Carolina, Ohio, and now Boston. Those are my places I've lived. North Carolina, Ohio, couple different cities in Ohio, Boston. So I've lived in Raleigh, Columbus, Dayton, Ohio, and now Boston. Hi, Olamaro. What are your thoughts on marriage and children? Is it overrated? Groove Toot says, crazy question. Well, I don't mind if people want to have, children, and then if they want those children to study physics, and then they come to me. So I'm all for it. I say, everybody have children. I'll be the auntie, the physics auntie, and send your kids to my channel. Also, you can send them to Boston for school. There's a lot of schools here in the Boston area. And yeah, so good. I think, I actually don't think of the children and the marriage thing too much as the same thing. I think that both are, you know, have their own importance in their own individual, specific ways. So, like, marriage is a very important decision. It's a very big decision. It's a very financial decision. And, you know, gotta be pretty careful with that. The next thing is the children thing, you know. That doesn't have to necessarily depend on marriage. You could be, you know, you could have kids without that. And also you could adopt. During warm weather, do you enjoy walks in Boston Common? Yes, I love the Common. Yes, I love Boston Common. I actually love that whole area. Like, I've walked around, you know, Beacon Hill and Back Bay and all of that whole area. Because I just like to get dropped off at any of the T stations. And then pretty much Boston is really small, right? So, like, even if I get dropped off at one of the T stations, I still can just walk around and do like a full exploration of the whole area and like maybe get some food, maybe get some bubble tea, and then take the tea and come back home, you know. So I love being in the Boston area, but also like kind of close to the Boston area where I can take teas in and out of Boston. So it's nice. I do like Boston Common and just that generally that whole area. I did my birthday celebration close to there. My birthday's in October, and so I had all my friends go to Estella. That was the restaurant. Do you know Estella, Ben? In case you're also from this area or know about the area. So I had gone to Estella. Actually, it was last year. It was around this time. I got like a Christmas brunch by myself. I don't know if it was on Christmas Day or a different day, but I got a brunch there. And then let me just say that the brunch at Estella was amazing. Just amazing. Amazing food. And like, I got a drink that the bartender like thought up right then, and he was kind of like high, and so he made up a new drink for me. And it was good. And then he made it again, and you know, whatever, that was good, but the food was really good. So the brunch was a good idea. When I went back for my birthday, the dinner was good too. I just think that the brunch was better, in case you're looking for a place near Boston Common. Ooh, and I also really like Paradise for breakfast near Boston Common. Since you mentioned Boston Common, now I'm thinking about all the food options near there, you know, because I'm not going to just take a walk there. I'm going to eat as well. So I'm thinking about, ooh, and in the summer at the Boston Common, Estella. Yeah, let me just make sure. Yes, Estella. Yeah, you should try it. But go for brunch. Yes, it's called Estella Restaurant. Estella. It's very close to Boston Common. American restaurant offering brunch, small plates, and late night bites, plus live entertainment. So, yeah. There is a serious discussion happening here on marriage and kids. Both terrify me, haha. I'm 28 years old and my family thinks I'm gay because I'm afraid of both. I wish you all the luck. It's definitely no small task, but parents were the same way and got married in their 30s and had me at 37, so no need to rush. Aww. Well, that's a really good comment, Groove Toot. I hope you figure it all out. That's a very nice comment, Groove Toot. See? Groove Toot is giving so much encouragement. Yes, I know my grandmother had her last child after 40, I think. So you got time, Crazy Sick Wine. It's totally fine. And if you do want to have kids, you might want to have them later, because then when you're old, they're not that old. You know what I mean? And generally, because if you have them young, they're going to be old when you're old. I don't know what I'm saying, but just saying, just throwing it out there. I'm giving you further encouragement along with Groove 2. But also, if you want to have them young, go ahead. That's fine too. 28, by the way, is a very young age. So I don't think there's any rush. That makes sense? Oh, thank you. Yeah, so my grandmother, one of my grandmothers, probably the kid that she was the most close with was her youngest kid that she had after 40. So, and like the whole the age thing is really, the biological thing really affects women more than men, right? So like if you're a guy, I guess really no rush. And if you're a woman, I mean, there's still time. People have them late, and then also there's adoption and other things, like surrogacy. I don't know. I'm not an expert on this topic. I only know physics and cats books. See, my channel is #cats and books with physics as my background. I don't know biology, and I don't know kids and marriage and all that. But I do think that it's a good thing to take your time and breathe in and out. And yeah, 28 is young. I mean, I think, yeah, I think people feel a lot of pressure with their careers too sometimes. And I feel like a career is actually so long, right? To find something that you want to do like lifelong, it can take time. But when you find it, it'll be great, because careers are long. And I think marriages are supposed to be long. They're not always as long. But, same thing, same sort of thing. It can take some time to maybe, I don't know, get there. Any other life-altering questions? Never let them get too close to me. Oh. Okay. I don't know what I want to do for my career. The only thing I really want is kids and a loving wife. I'll figure it out from there. Oh, wow, really? Huh, okay. Interesting. Yeah, I know people. I have some relatives or, cousins who are, yeah, I know people like that. I think there's a lot of people like that who they want a family, they want kids, and everything else is kind of like comes later. I wonder what that's like. I'm more career focused, I think. It was never my dream to like have a family. Like, I have a family with the kitty cats, I think I'm very nurturing, and I like nurturing the kitty cats and myself and my career and home and stability. But I don't think I ever like really dreamed of marriage and kids. So yeah. I do know people who are like that though. Indeed. Indeed. Suji Mama is such a cutie. She's in my lap. I am gonna finish my hot chocolate with you guys. I won't start the next chapter today because I want to rest my voice. I'm enjoying reading your comments though. Keep them coming. I'm enjoying the chat messages. You guys are being very like insightful today. But I'm also happy to give you some Boston recommendations. Keeping it light. So yeah, I love Estella, especially for brunch. Oh my god, it was amazing. I might go back there. I don't know what I'll do on Christmas Day. I know I'm meeting my friend, but we haven't decided exactly what we're doing and where we're going. So we'll see. I'll see what's open. I got Nepali food today, so that was amazing. I made sure that I was there by myself because I wanted to focus on the food and inhaling it. Like I can't really eat Indian food or Nepali food, like South Asian food, at a normal like a normal person. I have to inhale it. It's not like I generally eat fast, but I love it so much. I just don't want to focus on anything else when I'm eating. Crazy one, I really am wishing you all the best. The right woman will help you decide and get over all the scares that come with having children. It's hard even for people who want them. Yes. Oh yeah. I have friends who are having children or have had children. Excuse me. Like human children. And from the sounds of it, it sounds very hard. And it sounds like a lot of work. You could find somebody who doesn't want children if you don't want children. What's your favorite Indian food? I've really only had curry. Well, curry is a very general term, you know. So, Indian food. So, I mean, Indian food, the Indian cuisine, not that I know anything about cuisine, but in my own experiences, the Indian cuisine is very vast and diverse. And really, like, what do you want to know? Like, I love, if you're, simply put, I love butter. I love rice. I love eggs. And I love Bengali food. I'm from Bengal in India. Pretty much any Bengali dish, aloo bhaja, rice, dal. I just like rice with some kind of Bengali style dal with aloo bhaja or a potato dish on the side or any other veggie dish on the side. That's probably my favorite meal of all time. It could even be a boiled egg on the side with the rice and the dal. Thank you. Hi, Nausat. Definitely wish you the best as well. Life's short, groove to do what makes you happy and stay positive. Yes. We're being so wise today, but yes, definitely do what makes you happy. Oh, you guys are so loving. Yay. But yeah, I think it's a valid concern if somebody finds having children to be difficult, because I think it is very difficult. The people who have kids are they're very they have to be very committed to that whole effort. And it's not just like for a little while, right? It's like after 5 years of having a kid, the kid is only 5. That that is very concerning indeed. uh that's deep. What's deep? Oh, the makes you happy thing. Yeah, yeah. Whatever I'm saying is probably just weird. But I did think that kids are tough, human kids, from the looks of it, from when other people have it. Have you ever visited the Great River Ganges? Yes, I'm from there. I'm from Kolkata, so I was with the Great River Ganges growing up. The after 5 years of having the kid is only 5 is deep. Yes. Have you thought about that? You spend 5 years taking care of a whole human, and after 5 years, there's still only 5. After 10 years, there are only 10. See, do you see my stance on this whole thing? I hope it's becoming more clear. No, stay with me. Sachi's purring, but she won't let me hug her too tight. They were for the longest. I mean, yeah, they were going back and forth, visiting and stuff, but no, now they live in the US. It took them they moved after me, more recently. But yeah, no, they've moved as well. But they were sort of like in both places, and sort of more recently they have moved over more to here. But they're not in Boston. We're still in different places. We used to be on different continents. Now we're sort of in the same continent. Sachi! No, no. Oh, Sachi is not staying in my lap anymore. After 5 years, there's still 5. Yeah. I don't know what these people... The people who have kids young, though, I will say, the other flip side is that they are young when their kids are old. Like, you could still be very young and your kid is like 20. Kind of like my parents. They had us young. I don't know. Whatever. Not my field. Not my expertise. Sounds hard, man. Sounds hard. How many siblings do you have? Guess. You guess. Guess how many siblings I have. 4.5. No. I have one sibling. Just the one. I think we're each like an only child though. But yeah, I have a sibling. Just one. I have an older brother. How many siblings do you have? Sister or brother? Older brother. Broha. It's a bra. It's a bra. Just one. You're the older brother. Do you have a sister? Do you have a sister? No, 14-year-old brother. Oh, wow. Oh, he's a kiddo. I've always wanted one. Sister? So now I'll just have daughters. Yeah, that sounds good. I was gonna say you'll probably end up having your own kids who are girls. There you go. I'm looking at my statistics. Channel statistics. Oh dear God. I have so much work to do. I do. Do you have a bow in your hair? Yes. It's a hairband. Like it goes all around. Yes. Thank you. Oh, I like it. Thank you. I do like hair accessories. Crazy Sick Wine, do you have any more insights for us today? Or any other questions? Deep, life-altering, existential crisis type of questions that we want to cover? I'm all for it. Let's go. Christmas special. Christmas special. Let's go. I am hanging out with my friend and not exactly sure what we're doing yet. One of my best friends. And do you have any favorite traditions for Christmas? I like going to Europe every year. Not for Christmas, but for my birthday. This birthday, I didn't have the budget to do it. But yeah, generally speaking. So out of all the different festivals, the one I like the best is my own birthday. I like to celebrate my birthday immensely. And yeah, I don't really take the other holidays too seriously because, well, I like Christmas a lot. I like all the festivals. I just don't necessarily stick to the one same plan every year. Actually, I kind of like to stay home with the kitty cats. My kids, you know. I like to stay home with with my kids who are cats. Touch wood. Thank you, God. Thank you, universe. And enjoy my blessings. Touch wood. That's what I'd like to do for Christmas, and my friend can join me and we can get some food. Basically, I just want to hang out, have food, chat, have deep, long conversations, maybe go out and see the lights, but I don't want to like freeze in the cold either. So if somebody were to like drive me around and show me the lights and then we get food, I think we'll probably get an Uber. But you know, I'm big on like a party of 2 or 3. I like to spend time in a, with a small circle or just me and the kids at home, nice long chats. That type of stuff is my thing to do. More of my favorite, more social thing to do. Where in Europe? Dude, anywhere, man, anywhere. I love it. I love it. Hopefully somewhere I haven't been yet. But my favorite is London, but after that, anywhere. I just want to fly into London and then take a train anywhere. I live in Swim. Once I'm in London, I miss it so much. Once I go to London, anything is possible. Anything is possible. I take a train, I take a tube, I do anything I want. That, or I'd like to. This year I wasn't able to, but I'd like to do something like that for my birthday, you know. And I tried to celebrate my birthday in some way or shape. So that's sort of the tradition. It doesn't have to be Europe, but I like to celebrate and do something good. This birthday, I think I just worked, and then wait, what did I? Oh yeah, this birthday I ate a lot of food. Thank you. Me too. I hope you can next year then. Yes, indeed. This birthday I got myself a lot of breakfast food and I worked. And then I went out on the weekend and I got dinner with my friends, like I was mentioning, in Boston at Estella. And it was really great. They treated me, my one friend, like, they were very generous. I didn't have to spend money on my birthday or for my birthday celebration. And then we went to a bar. Yeah, so I caught up with my friends. I just want to do something nice, like something celebratory for my birthday. I think that's the one that I am more concerned with. The other festivals, I'm more flexible. I don't have to do I don't have to be super strict about exactly what I do. But I will say, I make it a point to celebrate the birthdays, like my birthday, my family, my mom's birthday, those types of, if I can, I'll try to celebrate it with them. And for my own birthday, I like to be with my kids. And so I like to be local. Like, I might do a trip around my birthday, but then I want to be home with myself and my kids and like do something here, I'm like a homebody as well. But like I like to be with Fuji Suji Baji. Because I tried one time, I actually like preponed returning from a trip because I was like, I want to be home for my birthday. Like I planned a trip, but then I caught an earlier flight back. Even though I was having a really good time, during the trip, but I was like, actually, I want to be home for my birthday. So I came back early. But yeah, next year, hopefully I can. Yes, indeed. Thank you. But pretty much, yeah. I just want to celebrate my birthday. Christmas. Christmas has a nice like cheer about it. Like today when I was working on my car, I saw the lights. I saw some of the Christmas lights around this area. That was nice. See, for me, that's enough. I'm like, I got a little bit of Christmas cheer today, and I'm wearing like my Christmas sweater slash, colors. So I think I like the holiday spirit and the festive spirit more than anything. I don't have to necessarily like do a specific thing for it to be, yeah, and hot chocolate. Exactly. Like I think exactly. Like I like the holiday spirit, holiday cheer, and things like that more than like I don't really need gifts. I don't really like buying gifts. Well, actually, not. That's not entirely true. I do like buying gifts, but it's less about that for me. What are you guys gonna do for Christmas? Oh God. I like getting gifts for people, but OMG, I still don't have anything for my mom. She's so hard to. Then you better hurry. Hey Google, what day is it today?
Today is Monday, December 23rd.
I mean, I've probably bought Christmas gifts on Christmas Day myself. There's some good deals. Maybe go to like a TJ Maxx or Marshall's. They'll have good deals on Christmas Day morning. Like, I mean, I've done it. I'm not judging. I've done it myself. She's the only one I haven't got for yet. But I've only done it when it was like a last minute plan. Like the, person didn't tell me that I was doing Christmas with them. Like some weird thing like that. I'm not judging. You know what? Get her some leggings. Or like home slippers. I need some home slippers. Like I have some, but I wouldn't mind like new ones. I think, yeah, no, those are the types of things that we like, the ladies. Some leggings could always, you can't have enough leggings. So, see? I know that she loves leggings. Yeah, yep. I'll just tell you my list, okay? All right. You can't get me enough leggings. You can always get me more leggings. Even if you got me leggings last year, just get her leggings, dude. Go to Costco and get her some freaking leggings. What are you doing? Even if you got me leggings last year, please get me leggings again this year. Ooh, socks. I can't have enough socks. Look at this. These socks, they're Christmas presents. These socks right here. These socks that are like more woolen-y, more woolen socks, like deep winter socks, deep winter, where the winter hits and you want more socks. You could do socks. You could go to like a Marshalls or TJ Maxx and get like socks, leggings. Moms are not hard to shop for. In fact, when I did a ton of Christmas shopping, say for like my partner's family members, something like that, because in my family, we don't take Christmas so seriously, right? So pretty much when I've been with somebody who was like Christian and they like, Christmas was a big deal for them, I always find it easiest to shop for the mom. I overshop for the mom, actually. I know exactly what they want. They want home slippers, because like, and I mean the slippers that are like fuzzy and warm. Because even if they have some, they're probably worn out. So they want slippers. They don't have to be Ugg slippers, because I know those are expensive, but you could get some like fake Uggs, or like not Uggs, but similar to Uggs, but they're still like warm and fuzzy. And it's just so nice to put your feet in them, and then you sit around the tree and sip some hot chocolate with some alcohol in it. That's what a mom wants, you know? I got her some Santa once last year. What, slippers? So yeah, leggings is a big one. Home slippers. Socks. Oh, do you mean socks? Maybe like a sweater like this. We can't have enough sweaters. Socks. Okay. See, for my mother, I don't do these things for my mom because I just get her jewelry. I don't like buying cheap things for my mother. And I don't really do Christmas. But if I go travel someplace and I find like fine jewelry, I get her that. Because she has enough clothes. She's like me. We're both clothesaholics, right? So I let her buy me clothes rather than me buy her clothes. Because I mean, I've done it. I've done it. I've gotten her clothes, but there's no way I can outshop her in clothing. Because she's like a member of Old Navy or Gap or something. Like, if anything, she's probably got it all sorted out, you know, like she's probably got some type of thing that she got for herself and another one like for me. So like most of my actually yeah, most of my a lot of my clothes are probably bought by her. And I'm sort of like we're covered, you know. It's not, clothes are not what we really need at this point. um but if I bought her a dress, she'd be happy. But she has a ton of clothes. She has a ton of dresses, and I feel like she knows what she wants clothes wise, and she gets it. She and my dad go shopping for clothes a lot, more than me, more than I ever do. So she's like set. If anything, I'm like, when you're at Gap, maybe get me this. With your points. They're like points shoppers, you know. They they get points and then they shop. Like we don't really shop. My family, we're all about the deals and the points. We don't really care about Christmas. Like Christmas is when you have a deal, you know. So we don't really shop when other people are shopping. We wait for the deal. So when they deem it fit to buy clothes, they do it. And at this point, I have a lot of clothes, and I've also donated a lot of, I like had to get rid of a lot of clothes. So at this point, they'll probably buy me some kind of clothing item. and socks and stuff. Like, I don't even bother. I clothes shop for myself maybe once a year or once every 2 years at this point. I don't even like do it really. But they get me some stuff sometimes. Yes, okay. I will be getting my mom some leggings. Yay! Thank you. Of course. I love the live, but I gotta go to bed. Okay. Good night. Merry Christmas. Bye-bye. I didn't realize we would be talking about Christmas shopping today. But here we are. We talked about Christmas shopping. Thank you, everybody. Thank you, everyone, for being here. Yeah. But yeah, I wonder when the next time will be when I go to a warm place and get me and my mom some fine jewelry. So like when I go jewelry shopping, I'll get her something and we'll like match. And when she goes clothes shopping, she'll get me something. That's sort of the deal. I don't really clothes shop. She does that. I jewelry shop. And we don't really shop, just period. We don't like to spend money. So it's kind of rare for me to go shopping. At this point, I haven't gone shopping. I think this whole, oh my God. Oh my God, it's December, right? Obviously, because it's Christmas. So the year is almost done. And I think I can think of the one time that I clothes shopped this year in the whole year. And it was for a pair of jeans, and that's it. I'm so proud of myself. Wow. I only bought a pair of jeans this year from Gap Outlet, after I got my haircut, I think. Because, yeah, I don't really go out driving, traffic, to, like, go get more clothes. That's tremendous amount of effort for me to go get clothes when I have clothes. I don't, because I have it. So, like, I'm good. I've also ordered clothes from Amazon. So I like when clothes just come to me. I don't really go out and do clothes shopping. But yeah, the one time I can think of when I was out and about and shopped for some kind of clothing item for myself, like I tried it on and I decided that I'm buying it, I'm spending money on it. This year, in this whole year, was that pair of jeans. Wow. I mean, a while ago, I used to still wear the clothes from high school. I had to get rid of them finally when I moved again and again and again. Like, that's how I've gotten rid of some of my older clothes, because, like, my clothes are good for a long time. Thank you, God. So, yeah. I don't think I've spent much on, I think the money that I've spent is more on home repairs. Touch wood, no more. Didn't have any money remaining after all that. So, touch wood, thank you. No more. So yeah, that's my Christmas for you guys. I think I'll be live again tomorrow. And we will continue the particle astrophysics discussion. And even if, if there's other things you want to talk about or other physics topics, we can talk about that. I think tomorrow I have to visit and check on my car again. Make sure it's working. So I'll do that first. Then I will go live again. Because tomorrow we'll do another live. Oh, can you like the live, please? I want to get 10 likes. Thank you. If you could like the live, that would be amazing. And tomorrow we'll go live. I think 24th as well we'll go live. Christmas Day, I will try to do a real quick live to wish everybody Merry Christmas. Oh, and I just wanted to say thank you all so much for your support on the channel this year. Um, I'm really grateful and happy for all the support I've been getting from everybody for my YouTube channel, especially this year. I mean, this channel's been around for a long time, but we became more active this year. So I really appreciate all of y'all's support and love that we've been getting on the channel. Do check out our shorts, videos, and live streams. Yay, Crazy Sick One says I'm back. Hello. And I wanted to mention again that we are very thankful, and I'm excited to see all of the growth and exciting opportunities happening with the channel. And going forward too, we will keep on pushing and go for more growth and more happy developments, hopefully, with this channel. So thank you so much for all of your support. Hi, Crazy. How are you doing? Any last thoughts before I sign off? Ooh, and Heike, if you're seeing this later on, I look forward to your comments as usual, and tell me what you're doing for Christmas. And sorry I missed you earlier today. I was having car issues. Good morning to you in Finland. Good morning to everybody who sees this in their morning. No, just have a great night, get better, and we'll see you later. Thank you. Yeah, I need to recover fully. Okay, well, thank you so much, everybody. Please like the live, share the live. See you next time, tomorrow, and have a great Christmas week. If you're going to work on Monday, then I do hope that you're almost done with work this year and you're ready to just sit back, relax, and enjoy the rest of the year and Christmas and New Year's. And let me know if you see this in the comments, how everything is going. It was great to chat with everybody, and we will continue our physics discussions next time. And we can also chat about all these different insights that we talked about and continue that as well next time. Thank you so much. Bye bye. Have a great Boston Christmas. Thank you, Ben. Thank you so much. Thank you, Ben. Thank you, Crazy Sick One. Look at Suji. What? Okay, weird. Bye-bye. Bye, everybody.